Okay, we're still on non-ground-to-ground projectiles, and I want to do two examples with you today because you haven't seen either of these types, these particular examples yet, and I want to make sure that you realize, oh, okay. So now, the first one is a ball is hit at an angle of 20 degrees, no, at 20 meters per second at an angle of 53.13 degrees, zero point 0.5 meters above the ground, and it clears a fence 10.5 meters high some distance away. So it's like you're playing baseball. And so you give it an initial velocity of 20 meters per second. This is like 0.5 meters above the ground. And the angle is 53.13 degrees. And so it goes up, and on its way back down, it clears a fence, and it tells us that that fence is 10.5 meters high. Okay, so it doesn't clear the fence at the halfway point, right? It clears the fence on its way back down. You're not so strong that you can put it over the fence at the delta dy max. And it wants to know how far away, so you're looking for the delta dx. So in the x direction, we have Vix is Vi cos theta, and we can find a number for that when we put it in the equation. Not now. Why would you do it now? Because you just carry yucky numbers. And Ax is 0, and we're looking for delta dx, and of course we don't have the time. And in the y direction, we have Viy is equal to Vi sine theta, and that's up. We have Ay is 9.81 meters per second squared, and that's down. And we have delta dy, and the difference here is 10 meters, and it's up. Okay? And we don't know the time. So we're still going to use the quadratic to find the time. So delta dy is equal to Viy delta t 1/2 Ay delta t squared, and still fill your numbers in before you rearrange. So 10 goes in as positive this time, and then 20 meters per second sine of 53.13 delta t plus 1/2 negative 9.81 meters per second squared delta t squared. Still bring everything over to the left hand side. So 4.905 meters per second squared t squared minus sine of 53.13 is 0.8. So 0.8 times 20 should be 16 meters per second delta t, and then the 10 is positive, equals 0. Fill it into your quadratic. Delta t is equal to negative 16 meters per second, and it's negative, so it'll end up positive, plus or minus square root negative 16 meters per second squared, so that's going to be positive, minus 4 times 4.905 meters per second squared times 10 meters, and that term is going to end up getting subtracted this time, times 2 over 2 times 4.905. Okay, so delta t will equal 16 meters per second plus or minus under the square root. 16 squared is 256 meters squared per second squared, and this is going to be minus 196.2. So this time you're not adding them. This time you're going to end up subtracting them. So it's going to be t is equal to 16 meters per second plus or minus the square root of 59.8 meters squared per second squared under the root 9.81 meters per second squared. So 16 meters per second plus 7.733 meters per second over 9.81 meters per second squared, or 16 meters per second minus 7.733 meters per second over 9.81 meters per second squared. Hopefully you notice that they're both going to be positive. This one's going to give us 2.41927 seconds, and this one's going to give us 0.8427068 seconds. It does not become Russian roulette to pick which one. You need to go back up. There are two positive answers. Why? Because there are two spots on this trajectory where the ball has changed height by 10 meters. One is here, and the other is here. Okay? And which one is it that it lands on the roof? It's this one. Or clears the fence or whatever it was doing, right? The smaller one is when it's still on its way up, and the larger one is when it's on its way down. So it's the larger one you want, and so then it's the larger one you use, and the delta dx is equal to vi cos theta delta t, and the last term goes to 0. And so delta dx is equal to 20 meters per second cos of 53.13, and then times that 2.41927 seconds. And you get a delta dx of 29.0313 meters. Okay? So that's one example. Two positive times, and you have to stop and think about which time do you use. The second example is kind of cool too. Okay? In this example, you're not given the VI or the time. So it says a ball is kicked at an angle of 53 degrees and lands on a roof of a 6-meter high building that's 30 meters away. Okay? So this is 30 meters. This is 6 meters. It's going to go up and on its way back down. And this is 53.13. Okay? And it wants to know what is VI. So in the x direction, we have VIX is VI cos theta. We have AX is 0. And we have delta dx is 30 meters. In the y direction, we have VIY is VI sine theta, up. AY, 9.81 meters per second squared, down. And delta dy, 6 meters, up. Okay? So if we try to do what we've done in the past and go to delta dy is equal to VI sine theta delta t plus 1/2 AY delta t squared, we can't get the time here this time because we don't have the VI, right? So we have two unknowns in this equation, and if we have two unknowns, it means we need another equation, so we have to go to our delta dx. So delta dx is equal to VI cos theta delta t plus, of course, the term that goes to 0. Okay, and we have two unknowns again, VI and delta t. So the same two unknowns, and two equations. So take this one and rearrange, and I'd rearrange for VI, okay, because it's going to be easier to sub it in over here. If you rearrange for delta t, you're going to have to sub it in two spots. So VI will equal delta dx over cos theta delta t. All right, and now sub that in over here. So delta dy equals delta dx over cos theta delta t, because I've subbed in, and then times sine theta delta t plus 1/2 AY delta t squared. Now this might look nasty, but it's really not going to be bad, because this delta t is going to cancel that delta t. And so you're going to have delta dy is equal to delta dx, sine theta over cos theta is tan theta, plus 1/2 AY delta t squared. And now the only thing you don't know is delta t. So take the delta dx tan theta over, becomes negative, multiply both sides by 2, divide by AY, and that'll be your delta t squared. And now fill your numbers in. And once you get your delta t, then you could fill it in here and solve for your VI, because I'm going to run out of time. So 2 brackets, this goes in as positive 6 meters, minus 30 meters tan of 53.13, and on the bottom, negative 9.81 meters per second squared. Remember, that's t squared, and when you do this, you get 2.6328 seconds, and now fill it in up here, And when you fill it in up here, you should get 18.9911 meters before I run out of time.